All right, guys, let's look at lesson 6. I want to be doing some factoring with some polynomial common factors and factoring by grouping. So those are actually two different things here, but the first example here says find the greatest common factor for the following polynomials and then factor. So if we look at these questions A, B, and C, these look frightening, right? We've got a big bunch of brackets, but what I want to do is I want to look at what is common to both terms. So what I'm going to do is look at these terms, and I want us to look at this as if this binomial is just simply multiplied by the 2x. So that's a single term in my kind of mind. And of course, this other term would be the 5 times x minus 1 with a minus, right? And negative 5 times x minus 1. So if I look at each of those separately, sort of in terms of a term, pun intended, if I look at the x minus 1 here and the x minus 1, that is my common thing that I can take out. Just for example, like let's just think of that instead of 2x x minus 1, we could say that that's like 2xy minus 5y. But instead of a y, we have x minus 1. So what is common to both of these? X minus 1 and x minus 1. So what do? Is we put our x minus 1 common factor in front, and I'm going to keep it in brackets because it was in brackets, and then I'm going to divide that out, that common factor out of each term. Okay, and so of course x minus 1 divided by x minus 1 is 1, and x minus 1 divided by x minus 1 is 1, and I'm left with, what are our leftovers? We're going to put the leftovers in this bracket over here, 2x minus 5. Okay, so there's our common factor, and we're pulling out a polynomial common factor. So for example, if I look at this next one, we've got these two common things. So those would be our common, and what we would be left over with would be a k minus 2. So I'm going to rewrite this as k squared plus 5k minus 3, and I'm left over with a k minus 2. All right, let's look at C. So C, I've got an a minus b over here, and a b minus a here. What is going on? Almost common. If I have b minus a, I can rewrite that in the equivalent of negative a plus b, right? I can write 3 minus 4. That's the same as negative 4 plus 3. Hopefully that makes sense. That's a positive 3. And 3 minus 4, I could rewrite that with a negative 4 in front and a positive 3 behind. And that would, of course, be negative 1, which is the same as 3 minus 4, negative 1. So this b minus a is the same as negative a plus b. Well, I don't want a negative a plus b. I want a positive a minus b. So if I could only make this sign positive and make this second sign negative, I would have a positive a minus b. If I could switch those signs, what can I do to switch signs? I can divide out a negative 1. So if I take out a negative 1, divide by negative 1, we're getting good at factoring. Negative a divided by negative 1 is a positive a, and positive b divided by negative 1 is a negative b. And now I've got a negative a minus b. So I'm just changing what that looks like. If I wanted to if I wanted to distribute that negative back inside, I would still get back my negative a and my positive b. So what I want to do is I want to rewrite this middle term. I'm just going to transfer down the first term, 2m a minus b, and then I'm going to transfer down my third term right here, negative 7 a minus b, but it's this middle term. So what do I want to do with that? I'm changing b minus a into a negative a minus b. Well, but when I take that this is multiply. This is like saying negative 3n times negative 1 times a minus b. So what happens to the negative 3n times negative 1? It becomes a positive. So we get a plus 3n times a minus b. So this is all the math behind this, okay? Do you have to do this or think this through to this detail every single time? No. The shortcut is change these into the correct order and change the sign here to the opposite of what it was. If that would have been a positive, we would have changed it to a negative. it was a negative, we changed it to a positive. That's the shortcut. Okay, now I look and I say, what is common? A minus b, a minus b, a minus b. So I write down a minus b, and what's left over? 2m plus 3n now, right? The opposite of minus 3n, minus 7. So we write those leftovers, 2m plus 3n minus 7. Alrighty then. I want you guys to give these two a try. Okay, so pause the video, and why don't you give those two a try right now. Okay then, so I have a look, and I can see that my two answers there are 3 minus 2y times 7 plus 2y, and x minus 3 times 20x plus 4. So here I had the x minus 3 and the 3 minus x thing. I rewrote 3 minus x to positive x minus 3, and we changed this sign from a negative to a positive. Okay, and there we were able to factor that quite nicely. You need to pause the video and check your work. That's great. That'd be great. Now, the next thing we need to be able to do is we need to factor these polynomials with 4 terms. The way we do that, we won't do every single one, but let's do like A, C, E, and G. What I want to do is I want to factor my first 2 terms and then factor my second 2 terms, and then get my polynomial into something like this, where I've got a polynomial that is a greatest common factor. So for example, for these first 2 terms, x squared and 3x, I can take out an x out of both of those. And then when I do that, let's just get rid of those for a second here. When I do that, I want to divide by x, divide by x. So when I divide out the x squared divided by x is of course x, because remember x squared divided by x is just x, and 3x divided by x is a 3. Okay? And then this next one here, the next 2 terms, again, I'm going to look at 6x and 18. And when I look at those, what is common there? There's a 6. So I'm literally just going to divide out by 6. Right? There's no common variable. And I end up with x plus 3. Note the brackets are the same. Okay? And now what's common to both of those? X plus 3. And what is left over? X plus 6. There I have just factored. Okay, if we look at question C, again, I'm going to look at the first 2 terms. I've got a 2 and a 6 and an A and an A and a B, C and a B. So what would be common there? That would be the 2, let's just move this up a little bit, 2 and A would be common. So when I divide everything through here, both of these by 2A, we get a C. Right, the 2a and 2a cancel. We get c plus 3b, and the 5 and the 15, b and b squared. We divide those out again. We get a 5b, and when I divide those both out by 5b, we get a b, sorry, a c plus 3b. These 2 brackets should be the same, so that's a hint. If I've done something wrong, 5 divided by 5 and b divided by b, I'm left with c plus 3b. So now, once I've done that, what is common? C plus 3b and 2a plus 5b. That's my leftovers right here. Okay? Let's try the next one. 7x squared and negative 2xy minus 2xy. No common coefficient. There's no factor that's common to both 7 and 2 other than a 1. So the only thing I can take out of there is an x. And I get a 7x minus 2y, right, when I divide that out. Let's just show that. Divide by x, divide by x. And for the next 2 terms, I need, because this one here is negative and I need this to be a negative, I'm going to take out that negative out of the 35. And what's common there, I can take out a negative 5. I have 35 and 10. And when I divide by negative 5 and negative 5, I get a positive 7x minus 2y, because 10 divided by negative 5 is negative 2. And I needed that. I needed both of those to be common. So 7x minus 2y, and what's left over? X minus 5. Okay, let's look at the next one. There are a couple ways to do this. One thing I can do is I can rewrite this as m plus n times m plus n plus 5m plus 5n. Okay, if I look at this one, if I look at these terms over here, I can take out of there a 5. So I just want to rewrite this as m plus n times m plus n plus a 5 m plus n. Now if I look at this, I've got a term here, kind of a single term, and a term here. My common is m plus n. And when I take an m plus n out of the first two, that's what reduces. I'm left with an m plus n. And when I take an m plus n out of these two, out of this one, I'm left with a 5. So my leftovers here are an m plus n plus 5. It's a bit of a weird one. This would definitely be an excellence type of question. Do not even panic about it. Okay, so for lesson 6, I would recommend that you do probably at least 1 to 3 in your homework. Okay, and let me just double check that. No one's going to give you any heck for doing more than that. So lesson 6, let's just bop back here a little bit and double check. I think, yeah, 1 to 3 looks good. Okay, and I guess that's all of them. Okay, so good luck with that, and please do not hesitate to contact me if you have any questions. Okay, good luck.